Lesson 97, the Pythagorean Theorem. So today I want to talk to you about this guy named Pythagoras. And he lived a long time ago. Excuse me again. He was a Greek philosopher and mathematician, Pythagoras was. He was born on the Aegean island of Samos and was later associated with the school or brotherhood in the town Crotona on the Italian peninsula in the 6th century BC. Now, he is most famous for what's called the Pythagorean Theorem. He discovered a relationship in the right triangle with the length of the leg across from the right angle. And he called that let me switch to the pen, the hypotenuse. And it spells just like it sounds, hypotenuse. And his theory, or his theorem, which is provable and accurate, by the way, is that the square of side A plus the square of side B equals the square of the hypotenuse. And in this formula, we refer to the hypotenuse as C. A squared plus B squared equals C squared. That is one that you're going to use when trying to figure out the length of the hypotenuse or the length of one of the unknown sides when you have the length of the hypotenuse. So let's jump into example 97.1 and I will show you how that works. We are given a triangle and the length of side A is unknown. We don't know what it is. B is 4 and C, or the hypotenuse, is 5. So we're going to drop those in. We'll make our buckets just like we normally do. So we don't know what A is, so it remains A squared. B squared is 4, and C squared is 5. Okay, so that becomes A squared plus 16 equals 25. Well, if we subtract, we treat it just like any other equation. We solve it the same way. We subtract 16 from both sides, and that leaves A squared equals 9. So how do we unsquare A? We get the square root of this number. So A equals the square root of 9. And we know the square root of 9 is 3. So the length of A is 3. And we know in this instance that it's not going to be a negative number because distance, length, is never negative. Correct? It is always a positive. That is where your absolute value comes into play. So you could almost put in an absolute value symbol here because that's technically what we're doing, is we're taking the absolute value of the square root of 9. So there is no plus or minus in relationship to the hypotenuse formula. All right? So A would equal 3 in this scenario. All right, let's try 97.2. We are given, and sometimes you're not given something that will always work out, and this is one of those instances. So in this case, A is equal to 4, and B is equal to 5, and C, we don't know. So we have 4 squared plus 5 squared equals C squared. So that's 16 plus 25 equals C squared. 16 and 25 is 41. How do we unsquare? We do the square root of 41. Can we get the square root of 41 as a whole number? Nope. So C equals the square root of 41. And that's the answer. That's as far as you can go with it. Okay, because there are no factors of 41 besides 1 and 41. Moving on. 97.3. See how easy these are? These should be really easy for you guys because you have already done substitution so much. Now you just have to understand the relationship of this formula and how you would substitute these values in order to find the missing value. That's all you're doing. You guys should be able to do these wonderfully. All right, in this instance, A is unknown. We don't know what A is. We'll leave a blank for A. B is equal to 5. And the hypotenuse, C, is equal to the square root of 61. Okay? So we say A squared plus 5 squared equals square root of 61 squared. Okay? A squared plus 25 equals, well, the square of a square root is just the number within, so that's 61. So we subtract 25 from both sides, just like any other equation. A squared equals 36. A equals the square root of 36, so A equals 6. See how easy these are? You guys should be able to do these in your sleep. Moving on to 97.4. There is something called Pythagorean Triples. And all that is a set of well-known measurements that always come out to whole numbers. You do not have to memorize those. It is helpful, you know, if you want to memorize, like for instance, 4, 3, and 5. That's a famous one. If you have 4 and 3, the hypotenuse is always going to be 5. Another one is 5 and 12. The hypotenuse is always going to be 13. 8 and 15. The hypotenuse is always going to be 17. Those are things that you can memorize, but if you use a squared plus b squared equals c squared, it will always work. You do not have to spend the extra effort memorizing them, but there is the thought process that if you memorize the answer, just like memorizing your multiplication tables, it'll save you a step. It's up to you to determine whether or not you think it's worth it, or you just want to use the Pythagorean Theorem every time you need to figure it out. This is pretty easy, so if you struggle with memorization, just memorize the formula. That you'll get it right every time. It'll never steer you wrong. So let's, with that in mind, do 97.4. And we do not know the hypotenuse in this instance. We know that A is 8, and we know that B is 12. We don't know the hypotenuse. So 64 plus 144 equals c squared. So 208 equals c squared, right? So we take the square root of 208, and that equals c. Do we stop here? No, we do not. If we factor 208, we get that 4 times 4 times 13 is equal to 208. And we have a pair of 4s, so we can pull them out and say 4 times the square root of 13. And that equals c. And sometimes that is what your hypotenuse is going to look like. And that's okay. It's perfectly fine. If you can put this back into here and it comes out with the same measurements for A and B, then you're perfectly fine. Let's say you want to solve for B. We'll just backtrack it. So let's skip B and drop in C. So we would say 8 squared plus B squared equals the square of 4 times the square root of 13, right? And that'll be squared. So that'll be 64 plus b squared equals, and we know that we can square this and multiply it times this, right? So that would be 8. No, that'd be 16 times 13. And that is 208. So we subtract 64 from both sides, and that leaves us b squared equals 144, because 208 minus 64 is 144. So b equals the square root of 144. B equals 12. And that's what we started with. So if you can plop C in and leave one of these measurements out and backtrack it and it comes out to the right number, you know you're correct. You've just checked your answer and you've gotten the right response. So absolutely do that. But you do not have to memorize the Pythagorean triples. That's what they're called, the ones that always equal a whole number. You can just use the theorem and you'll get it right every time. So for instance, I'm going to go through these triples. These are some of the ones that are the most famous for you. 5 and 12 should equal 13 for the hypotenuse. So 5 squared plus 12 squared is supposed to equal 13. So let's put that in a box up here. That's C squared, right? That's 25. 144 equals C squared. That's going to be 25. That's 169 equals C squared. The square root of 169 is 13. So that's correct. All right, that's just one of the triples. So it's 5, 12, 13 is one of them. Another one we have, let me erase this too. We have one that says it should be 8, 15, 17. Okay, well let's try dropping out B. So 8 squared plus, oh, we're going to drop out B. B squared should equal 17 squared, right? Okay, I am going to pull up my calculator for use and do 17 times 17. That's 289. I don't have that memorized. This is 64 plus B squared. Subtract 64 from both sides. B squared equals 265. Okay. So B should equal the square root of 265. And that is, I think it's 15. Let's check it. 15 times 15 is, oh, you know what? 289 minus 64 is 225. I did bad math. Miss Tracy, that's terrible. 225 equals the square root of 225. And so that is divided by 15 is 15. So B is equal to 15, which is what it's supposed to be equal to. If you had memorized the triples, you would just stick 15 in there. You would know. You'd see 8, 15, 17. You would know. You'd see 8 and 17 or 17 and 15. You would know the third one, the third side. We are not going to worry about solving any more of the triples because you can just use a squared plus b squared equals c squared and always come out to the correct measurement for the hypotenuse or for side A or side B. And that is all we have for lesson 97. I will see you in lesson 98.